Hello, this is Dennis signing in. Welcome back to my channel, KO Math. In this video, you're gonna learn how to factor trinomials, x squared plus bx plus c, or x squared plus bx times something plus c times something squared. It is very important to know how to factor. It has many applications in algebra, trigonometry, calculus, among others. In algebra, you might need it to simplify expressions, solve equations, and to solve polynomial and rational inequalities. Most of the expressions that you need to factor are trinomials, sum of three terms, just like these expressions. Here, we discuss how to factor these expressions. The most famous way to factor this is factoring by trial and error method or guess and check method. Let's review this method. So here, if we want to factor x squared plus bx plus c, the first thing that we need to find are factors of this constant c here. We need to write it as a product of two factors, okay, m and n, okay, whose sum is equal to the coefficient of the middle term. So m plus n is equal to b. And if you're successful in finding these factors m and n, you can write this as a product of two factors, and the two factors are x plus m and x plus n. And you may check your answer that if you expand this product, you'll get x squared plus bx plus c. Let's look at this example. You have x squared plus 7x plus 12. So we need to find two factors of 12. So we need to write the 12 as m times n, wherein the sum of m and n is equal to this 7 here. Okay, so m plus n is equal to 7. So it's very easy to guess these factors. They are 3 and 4. So 3 times 4 is equal to 12, and then a 3 plus 4 is equal to 7. So therefore, how do we write the factors of x squared plus 7x plus 12? We can write it as x plus m, so that is a 3, times the quantity x plus n, so that is 4. And we may check that this is the correct factorization of this one by FOIL method. And what is that FOIL method? So FOIL method, so this word stands for product of first terms, and then product of outer terms, I, product of inner terms, and then L, product of last terms. So if we apply FOIL method to expand this product, we'll get x times x is x squared, and then x times 4 is equal to 4x, 3 times x is equal to 3x, and then 3 times 4 is equal to 12. Of course, this 4x and 3x are like terms, so we can combine them. So 4x plus 3x is 7x. So therefore, this is the right factorization of x squared plus 7x plus 12. Let's try another one. So here, let's factor x squared minus 2x minus 15. So keep in mind here that b is negative 2, not positive 2, and c is equal to negative 15, because we need to write our expression as x squared plus bx plus c. Okay, so we need to find two factors of c, so m and n, whose sum is equal to b. So in this problem, it's still easy to find those factors, and they are negative 5 and 3. So negative 5 plus a 3 is negative 2. So therefore, we can factor this expression into this one. So x plus m, so that is negative 5, and then x plus n, so that is x plus a 3. And it's better to simplify the factors, so x plus negative 5 can be written as x minus 5. So the correct factorization of this one is x minus 5 times x plus 3. Probably this is the fastest way to factor such a trinomial, where the coefficient of x squared is equal to 1 if you can figure out quickly the appropriate factors of c. In this case, you have negative 5 and positive 3. But if it is too difficult for you to find the appropriate factors, which is actually the problem of many students, I'll teach you here how to find them systematically, and you'll be assured that you'll be able to find them. Okay, let's try this one. Let's factor x squared plus 9x minus 36. So here we find two integers whose product is negative 36 and whose sum is positive 9. And let's do that systematically. So what we're going to do first is to take the obvious factors of negative 36. Obvious factors of 36 are 1 and 36, but since the product must be negative, so one of them is negative. But since the sum must be positive 9, for sure the negative sign is in the lesser number. So you have negative 1 and then 36. And the next thing that you need to do is to prime factorize 36. That is, you need to express it as products of powers of prime numbers. What is a prime number again? It is an integer greater than 1 whose only factors are 1 and itself. So one way to find the prime factorization is by this tree diagram. So you start with 36 and just think of two factors, for example here 4 and 9. So because of course you need to know your multiplication table. 4 times 9 is equal to 36, and then 4 can be written as 2 times 2, and then 9 can be written as 3 times 3. So all the numbers here are prime numbers. So if you can write a number as a product of two smaller numbers greater than 1, then for sure it is still not a prime number. Okay, so now we have to write it as a product of powers of prime numbers. So we have two copies of 2 here, so that is 2 squared, and then two copies of 3. We can write that as 3 squared. Now, to find the other combinations, okay, that will add up to 9, what we're going to do here is to pull out some factors of 36. Okay, let's start with copies of 2. So if we pull out one copy of 2 here, okay, every time you pull out a factor from this number, you have to multiply it to this one because the product must be equal to negative 36. So when you pull out the 2 here, you multiply that with negative 1, you'll get negative 2. So, of course, the new number here must be 18 because 36 is 2 times 18. So it's clear from this one that negative 36 is negative 2 times 18. Okay, but the sum is still not equal to 9. So again, we pull out another copy of 2 here. So that means we already pull out here two copies of 2. This one, two copies of 2, which is equal to 4, and we multiply that to negative 1, you'll get negative 4, and then the remaining factor here is a 3 squared, which is equal to 9. But again, the sum is not equal to 9, so negative 4 plus 9 is equal to 5. So now let's try to pull out some copies of 3. So if we pull out one copy of 3 here, then of course, you multiply that to negative 1, that is negative 3, and then the remaining factor here will be 2 squared times 3, which is equal to 12. And you may check it. Negative 3 times 12 is equal to negative 36. And the sum now is equal to negative 3 plus 12 is equal to 9. So therefore, we have obtained the two numbers that when we multiply, we'll get negative 36, and when we take the sum, we'll get positive 9. And we get the correct factorization, which is x plus m, that is x minus negative 3, times x plus n. This is our n, so that is times x plus 12. Now let's consider these two problems, x squared plus 3x minus 18 and x squared minus 14x plus 40. Let's try this first problem. So, of course, it's easy to factor this out by trial and error method, but here again, let's do it systematically how to find the two integers whose product is negative 18 and whose sum is positive 3. So again, let's take the obvious factors of 18, 1 and 18, and then since it is negative, so one of them is negative, but since their sum is positive, so the lesser number must be the negative number. So negative 1 and then positive 18. And then you do prime factorization here. It's easy to do that because 18 is 2 times 9 and 9 is product of two copies of 3. So again, the sum of this is 17. So it is not equal to 3. Now we try to pull out one copy of 2. So if you pull out a 2 here, multiply it to this one, you'll get negative 2 times 9 and the sum is 7. It is not equal to 3. Now we move to copies of 3's. So first let's pull out one copy of 3 and we'll get negative 3. So 3, if you pull out one copy of 3 here, you have to multiply that to this one to make sure that the product is equal to negative 18. So here, 3 times negative 1 is negative 3. And then, of course, if you pull out one copy of 3 here, the remaining factor is 2 times 3, which is equal to 6. Or just divide 18 by 3 and you'll get 6. And it is clear from here that their sum is equal to the coefficient of x here, which is equal to 3. So therefore, the factors are x plus m, so that is x minus 3, and then times x plus n, so that is x plus 6. Let us now factor this second expression, x squared minus 14x plus 40. So again here, first we factor out 40, and we'll get, of course, the obvious factors of 40 are 1 and 40. But take note, we're looking for two integers whose product is 40 and whose sum is negative 14. Okay, so therefore, the two integers must be negative for their sum to be negative and their product to be positive. So the obvious factors are negative 1 and negative 40. Okay, so again, we prime factorize 40, and this is 4 times 10, right? And 4 times 10 is, this is actually 8 times 5. Okay, 8 times 5, and you can write 8 as product of 3 copies of 2. So that is 2 cubed, which is 8 times 5. And 2 and 5 are prime numbers. So this is already the prime factorization of 40. Now, the sum of negative 1 and negative 40 is not equal to negative 14. So again, now we pull out some factors of negative 40. So if we pull out one copy of 2 here, so we have to multiply that to negative 1. So we can write it as negative 2. Of course, the remaining factor here will be negative 20. And as you can see, negative 2 times negative 20 is positive 40. What is their sum? It is negative 22, which is not equal to negative 14. So now we take out two copies of 2 here. So we'll get here, you have two copies of 2, so that is 4. You multiply that to negative 1, you'll get negative 4. And the remaining factor here is 2 times 5, and then it's negative, so that is 10. So from here, negative 4 plus negative 10, it's equal already to negative 14. So therefore, we found already the m and n. So the factors are x minus 4 times x minus 10. Let's try one more problem. So let's factor x squared minus 8x minus 84. And let's find systematically the two integers whose product is negative 84 and whose sum is negative 8. So here the obvious factors of 84 are 1 and 84. But since the product is negative, one of them is negative. But since the sum is negative, the larger number is the one that is a negative number. So if we prime factorize 84, we'll get this one. So 84 is 2 times 42, and 42 is 6 times 7, and 6 is equal to 2 times 3. So therefore, the prime factorization is we have two copies of 2, 2 squared, one copy of 3, and then one copy of 7. The sum of negative 84 and 1, it's not equal to negative 8. So now we pull out factors of 2 squared times 3 times 7 and multiply it to 1 until we get a sum which is equal to negative 8. And here, doing same steps as before, first we pull out some copies of 2 and then a copy of 3 or a copy of 4. Now it's a combination of 2 and 3. And from here, the sum of this is not negative 8, sum is not negative 8, but when you pull out one copy of 2 and one copy of 3, okay, so that is equal to 6, okay, so the remaining factor here is 2 times 7, which is equal to 14, and of course it's negative. Now the sum is equal to negative 8. And these are the integers that we're looking for. So therefore, the factors are x plus 6 and x minus 14. Let us now try to factor this kind of trinomial. So here we have y and y squared. So this is a trinomial of the form x squared plus bx times something plus c times something squared. So don't be scared about this y and y squared here because the method in factoring this trinomial is actually exactly the same thing as the previous problems. So here, what we're going to do is just find two integers whose product is c and whose sum is equal to b, just like in the previous problems. But you need to figure out what this expression is inside this rectangle. And then after finding these two integers m and n, whose product is equal to c and whose sum is equal to b, then the factorization, it is just x plus m times whatever the expression inside this box, okay, times x plus n times this expression. So here, x squared plus 4xy minus 21y squared. So your c is negative 21, and it's clear that this expression in the box is equal to y. So we do similar steps. So obvious factors of 21 are 1 and 21. It's negative, so one of them is negative. And since the sum is positive, so the larger number must be positive. Okay, and 21 can be factored out to 3 times 7. And then the sum is not yet equal to 4, so we pull out factor 3 here, multiply to negative 1, that is negative 3 times 7, and their sum is already equal to 4. So the factorization is equal to x minus 3 times this expression in the rectangle, which is actually equal to y, times x plus n times this expression, y. Let us now move to our last problem. So let's factor x squared plus 4xy squared minus 45y raised to 4. So here, the rectangle is equal to y squared. So y raised to 4 is equal to the square of y squared. Okay, so first we find factors of negative 45. Obvious factors are negative 1 and 45. Again, the negative sign is here because the sum is a positive number. And the prime factorization, 45 is 9 times 5, and 9 can be written as 3 squared. So the sum is not equal to 4. We pull out a factor 3 from this, and we'll get negative 3. And then that is the remaining factor is 3 times 5 or 15. The sum is still not equal to 4, so we pull out one more copy of 3. So that is pulling out 3 squared, and the remaining factor is 5. But keep in mind that the sum must be a positive number. So if the sum is a positive number, the negative sign must be in the smaller number. So we have to move this negative sign here to this one. So we'll get 9 and negative 5. And the sum is already positive 4. So therefore, the factors are x plus 9 times this box, which is equal to y squared, times x minus 5 times y squared. Alright, this is the end of this video. Today we learned how to factor these expressions. x squared plus bx plus c or this expression. So again, if it is hard for you to find the factors by trial and error method, then use the systematic way that you learned from today's lesson. My next video will be about the fastest way for me to factor ax squared plus bx plus c, where a is not equal to 1. Probably you haven't seen the technique that I will be sharing with you. So if you haven't subscribed to my channel, make sure to click that subscribe button below so you won't miss any of my videos. Again, this is Dennis of KO Math. Thanks for watching and hope to see you in my next video.